Hello friends, welcome to part 4 of real number. In this session we are going to look into the irrational number and its revision and the top 8 important questions that will be asked in this topic. So let's get started. Okay, so here is the definition. A number or numbers is called irrational if it cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. So this is the definition, friends. So what we will do next in the continuation session, I'm going to cover the topmost 8 examples which are related to this topic. So let's move to the next slide. Question number 1. Prove root 2 is irrational number. Similarly, we are going to have couple of more questions in this similar pattern, root 2, root 3, root 5. So we will look into those in the upcoming slides. So let's first understand the first question carefully, then the next question will become quite easy for you. So to prove any theorem or this particular question, what we will do, we will just think it in other way around. For example, the question is to prove root 2 is irrational number. So what we will consider now, let's assume root 2 is a rational number. So the moment any rational number is there, you can write it in the form of p by q, where p and q are co-primes. Co-primes, I hope you remember from the previous slides that if a number just have 1 as a common factors, there are two numbers. So if both of those numbers, if we'll find out the HCF, then 1 is the only HCF, then you can say that the numbers are co-prime. So let's write root 2 in the form of p by q. You can write it next down equal to p equal to root 2q. We will put square on both the sides. It will become p square equal to 2q square, which is our equation 1. 2 divides p square. You see here, you can bring 2 down over, right? P square by 2. That means 2 is capable of dividing p square. Then 2 will still capable of dividing the number p. Let's take example, if you are taking p as some random number, for example 4. So 4 square will become your 16, and the moment you are bringing 2 down over here, 4 square you can divide by 3, divide by 2, then you can divide 4 also by 2. So that is the main over here. If 2 is capable of dividing p square, then 2 also divides p, where p is an even integer. Why it's even integer? Because you are dividing p by 2, and 2, if any number is getting divided by 2, that means it's an even integer. So now we will consider p equal to 2a. Definition of an even number. A is positive integer. So let's do one thing. We have considered that p is an even number. How you can notify any number as an even number? You can just put 2 in front of that, and any number which is getting multiplied by 2, it will become an even number. So we have considered p equal to 2a. So looking into the previous equation, p square equal to 2 square. Now you replace p with 2a, it will become 2a square equal to 2q square. So you can write it down, 4a square equal to 2q square, and q square will become 2a square. Here, if you remember, look at this line over here. P square equal to 2 is 2q square, where we have said 2 is capable of dividing p. Same thing you can see over here, 2 is capable of dividing q. That means 2 is now able to divide both p and q. So both p and q have 2 as a common factor. Now student, if you try to recollect what we have said over here, an irrational number should not have any common factor other than 1. I'm sorry, a rational number should not have any other common factor other than 1. But what we have seen here, p and q have 2 as a common factor, which is definitely contradicting our statement. We said at the above that root 2 is a rational number, and if root 2 is a rational number, it should not have any common factor other than 1. But after going through the equation, what we are able to find out that 2 is again a common factor of p and q. So This is contradicting our own assumption. Hence, we can say that root 2 is an irrational number. So let's go to the another slide. Question number 2. Prove root 3 is irrational number. So we will follow exactly the same approach how we had followed in the previous slide. So what we will do here we will assume it other way around, that root 3 is a rational number, and the moment root 3 is a rational number, you can define it in the form of p by q, where p and q are definitely co-prime number. That means they will not have any other factor other than 1. So now how you can write it? You can write p equal to root 3 q. Now you apply a square on both sides. P square will become 3q square. This will become your equation 1. Now here if you see, 3 can divide p square. 3 can divide p. So p by 3. It does exist. So what we can do? P by 3 equal to a, where a is some integer. How you can write it down now? P equal to 3a. And let's put this p equal to 3a in equation number 1 over here. P square equal to 3q square. You just replace p with 3a equal to 3q square. It will become 9a square equal to 3q square. And now you can very easily divide it, and it will become your q square equal to 3a square. And again, if you pay attention over here, this particular line and this particular line, it's just the same. Here 3 is capable of dividing q square as well as q. That means in equation 1, 3 was capable of dividing p. And here at the bottom of the slide, 3 is capable of dividing q. That means p and q have common factor as 3. So now if you see and if you notice, the common factor of p and q are 3. That means it's just contradicting the fact that we have assumed before. We assumed that root 3 is a rational number. And if it is a rational number, it should not have any other common factor other than 1. But here we can see that 3 is a common factor. That means our assumptions was wrong. And root 3 is an irrational number. So let's move to the another slide. Okay, so we are now at question 3. Here you have to just prove root 5 is a rational number. So I think now we have seen the two questions, similar two questions in detail. So I'm not going to explain this question again. But if you see here, again here we have taken the same approach. And at the end of the slide, you can see p and q have common factor 5. And definitely if it has a common factor 5 or an integer other than 1, that means it's not a rational number. So root 5 is not a rational number. So definitely it's irrational number. So we will go to the next slide and look at the other type of questions. Question number 4. So here we have to prove 1 by root 2 is a rational number. So by look and feel, you can say it's a little bit different, but the approach will remain still same how we have learned in the previous slides. So here also we will assume 1 by root 2 is a rational number. So the moment it's a rational number, you can represent it in the form of p by q. So how you can write down? The q by p will become your root 2. And you already know from the previous slides that root 2 is an irrational number. So root 2 is an irrational number, whereas p by q is a rational. Since irrational is not equal to rational, this leads to a contradiction. So guys, look, if you are writing some equation like this, p by q or q by p equal to root 2, it is assumed that whatever value we have on the right hand side will be same as that of the left hand side. And if the values are not same, that means this equation is not true. That is why we have written it over here. Since rational is not equal to irrational, this leads to a contradiction, and we can say that 1 by root 2 is a irrational number. Question number 5. It's again the same. 7 root 5 is an irrational, you have to prove. Similarly as that of the previous approach, 7 root 5 equal to p by q. How you can write root 5? You can write root 5 equal to p by 7q. And we already know that root 7 is irrational number, and this part right hand side is a rational number. So definitely again in this case also it's not the same. So this leads to a contradiction, and we can say 7 root 5 is irrational number. Let's move to another slide. Okay, question number 6. We have to prove that 5 minus root 3 is irrational number. So again, approach will remain same. What we are going to assume, 5 root 3 is a rational number. So let 5 root 3 is equal to r, where r is a rational number. So now how you can represent 5 minus r will become root 3. You can write it like this also, right? So now you already know root 3 is an irrational, and this part left hand side is a rational number which will again not hold true. So this leads to contradiction, and you can say it's irrational number. Going to question number 7, we have to prove that 3 plus 2 root 5 is irrational. So what we will do, again we will assume that 3 plus 2 root 5 is rational, and we can write it in the form of p by q. You can represent 2 root 5 is equal to p minus q, p by q minus 3, and lately you can write it down, root 5 is equal to p minus 3q by 2q. So if you see here again, left hand side is our root 2, which we already know is irrational number, and the right hand side number, this is a rational number. So again, rational is not equal to irrational. So the contradiction or the assumptions that we have made is contradicting, and we can say that 3 plus root 2 is irrational number. So now we will move to the last slide of the session. So we are on question number 8, and we are on the last slide of the section. So how I'm going to take the approach for this example, we will be looking the two methods for proving this particular questions. You just take up the methods which suits you the best, but approach is still going to be the same. So what you have to prove over here, 6 plus root 2 is irrational number. So again, 6 plus root 2 is irrational is equal to r, where r is rational. 6 minus r equal to root 3. So here again we can see right hand side root 3, left hand side 6 minus r. That means right hand side is irrational number and left hand side is rational number, which is not equal to. This leads to a contradiction. Hence 6 plus root 2 is irrational number. And we will look the same question with another method. So assumption or approach will still remain same. 6 plus root 2 is rational. Hence we can write 6 plus root 2 in the form of p by q. And then what you can do, root 2 will become p by q minus 6. And finally root 2 you can represent in this form, p minus 6q by q. Hence root 2 is irrational number, and this particular portion which is on right hand side is a rational number. So again, rational is not equal to irrational. This leads to the contradiction. Hence we can say that 6 plus root 2 is irrational number. So guys, we have covered part 4 of real number, where we have just revisited the irrational number again, and I have just taken all the important and the more recurring questions that are coming in examination. So once you go through it, I think you will be able to cover all the questions which are coming from this topic. Thank you for watching my video. If you like my video, request you to please like, share and subscribe. I will be coming soon with the last part of the real numbers, and by that we will be able to cover the entire real number. By that time, please take care. Have a good day. Bye.